The two types of bridges needed to build a 3000-meter bridge with minimum cost and optimum safety. Bridges are defined as a structure that spans horizontally between supports. Bridges function to carry vertical loads. The three laws of physics involved when designing and building a bridge are Newton's first law, Newton's third law, and Hooke's law. Newton's first law states that the forces acting on the bridge should be equilibrium. For a bridge to support a load, the upward force should be equal to the downward force. Next, Newton's third law of motion: for every action there is an equal and opposite reaction. This is because it is impossible for a single force to be acting on the bridge. Finally, Hooke's law explains the amount of restoring force needed to bring an object back to its original position after a force has been applied. Hooke's law is useful when choosing the appropriate materials for building a bridge. The first type of bridge is cable-stayed bridge. Cable-stayed bridge are similar to suspended bridge in that it has towers and a deck that is held by cables. The cables hold the deck by connecting it directly to the towers. Cable-stayed bridge carry the vertical main span loads by nearly straight diagonal cables in tension. The tower transfers the cable forces to the foundation through vertical compression. The tensile forces in the cables also put the deck into horizontal compression. The advantages of cable-stayed bridges are: firstly, they are strong. They have great stiffness which can handle more pressure. As a result, the deformations of the deck under live loads are reduced, and the deck has more rigidity. They are also more resistant to environmental changes such as earthquakes. Cable-stayed bridges also take less time to build, since they require few cables and don't require anchorages. They are also economical as they require fewer materials and less hours on building. Next, box girder bridge. Box girder bridge is made of the key beam, which consists of girder shape which looks like a hollow box. This type of bridge can be used as long span bridges where the actual self-weight of the bridge has to be kept minimum. The box girder has high torsional stiffness, which increases the strength of the bridge. Torsional stiffness is a characteristic property of a material which signifies how rigid the material is. This shows how much resistance is offered per unit degree in its angle when twisted. The greater the torsional stiffness, the greater the load it can bear within allowed distortion. Finally, the improved durability from the box girder bridge and reduced maintenance of protective coating help reduce cost of maintenance of the bridge. The two types